All right. Sure that I got my pens here. They're working. The orange one. All right. This is literally review pre-calculus last year all in one. Okay. So we're going to do logarithmic functions. I'm going to review with you why, because we're going to take derivatives them on Monday. Yay. Okay. So first things first, you need to remember what the common log is, common logarithm. That's the one that you actually see on your calculator that says LOG. Okay. And that is a log of base 10. When you see that on your calculator and you press it, what you're actually doing is log base 10. And it's written like this, log of x equals b. I'm going to say b. So again, there's an understood 10 right here, but that 10 is not written. Okay. So how do I rewrite this exponentially? This is the log way of writing it. Do you remember how to write it exponentially? If I go like this, yes. So the rule says that log base 10 of x equals b if and only if, and then you do that whole zoop like that. If and only if 10 to the b equals x. This is what we call the exponential. This is the log way of writing it. Exponential form, logarithmic form. So if I had given you this and I said write it as a log, you'd still go and you'd say log base 10 of x equals b. Oh, that's what that is. But just so you, again, you know that 10 is unnecessary. It's an understood 10. Just like x has an exponent of 1, log has that. But we are going to take derivatives of logs, by the way, but we don't really use them as much in calculus. We really do use natural logs a lot more because they're much more beneficial and quick. And they get rid of the following. A natural log is a log. It actually is the word, it's a log, but it's of base e. So that's why we use it more often, because it actually can get rid of the e's for us. And we don't actually write the word log e, we write ln. But ln actually stands for log base e. So ln x equals b. So again, there is an understood e right here. We just don't write it. Again, not written.
What does ln stand for?
It actually stands for some Latin word like logarithmic naturalis or something. Like, it's very interesting, but that's what they changed it to. Instead of writing log e, they wrote ln. And I didn't make it up. It's just what they did. So let's see if we can write this exponentially then. So how would I write it exponentially? What would I do? E to the
Power b
equals x. Okay. Logs are just exponents. Exponents can be written as logs. That's all they are. If you can just get that in your head, that's really what they are. Logs and exponents. All right. So God bless you. So let's do this as, this will be our natural. This will be the first part of your homework tonight. You'll be writing it either as a log form or an exponential form. You just need to know how to switch from one way to the other. That's all. Okay. Let me do this, move this up here. And I'm actually going to write them all like this because I want you to do all of these, figure them all out without a calculator. I take that back. There's this one right here. This last one is the only one you'd actually need a calculator for. And I'll show you why in a minute. Okay. So the natural log of 1, you can actually figure that one out without a calculator. And again, here's how. What you're supposed to do is you set it equal to x. Again, this has a base e. So you go like this. So e to the x equals 1. Well, how do I get 1 to be a base e? E to the 0, which means x must be 0. If you punch this in your calculator right now, ln 1, the calculator will say it's 0. Ln of 1 is 0. Okay. What about ln e? Do you know what the answer to ln e is? 1. Very good. ln e is 1. And again, if you did the whole thing, e to the 1 makes e. e to the 1 makes e. Put a big huge star right here. This one is your best friend. This is what's going to help us when we go to solve E problems or when we solve LN problems. You use them, which we'll get to talk about in a minute. All right, so this one, ln of 1 over e, anybody know what that would be? -1. Again, if you set it equal to x, which you can do, and you do the whole zoop, you say e to the x equals 1 over e, or e to the x equals e to the -1. So it must equal -1. But this is the only one that you can't do, and again, I'll show you why. If you put x here, e to the x equals 2. E to the x equals 2. So you're saying, well, what power of e makes 2? Well, it's a very tiny number. It's like a decimal, but you can punch in your calculator, ln2. Your calculator has it right there, ln2. And I believe it gives you like 0.69-ish, something like that. Okay. So you just need to know how to go from this exponential to this log, or from log to exponential. Let's literally the first part of tonight's homework, please. Like tonight's homework, they gave you this. They actually wrote ln 8.4 equals 2.128, and they want you to write it as an e. So you just go, okay, e to the 2.128 equals 8.4. You just do the whole c thing for those first parts. All right. Then I want you to remember what the graph of these look like. The graph of f of x equals e to the x, and the graph of ln x, okay? I'm running out of room here, but I can squeeze it in. So e to the x is obviously exponential. It's going to go through 0, 1, and then it's actually going to go through 1e. That's that point right there. That's e to the x. The graph of ln of x goes like this. And what can you tell me about those two? They are inverses of each other. Jack, you disappoint me. They are inverses of each other. Why is that important? Because to solve for an e, you have to take the ln. To solve for the ln, you do e. Remember me saying that kind of last year, maybe? No? At this very moment, I was teaching you the same thing because I'm teaching it to the other children today. E's and ln are inverses of each other. They will cancel each other out. So make sure you know that. All right, so let's do a couple quick examples of that. What they'll do tonight for homework here. There we go. Okay, so part 3, simplify. No calc. You'll see why it's so easy. You don't need a calc. The ln of e to the root 2. Number 2, the ln of e cubed. Number 3, e to the ln 3x. And number 4, e x plus 1. Okay? Super simple. If they're inverses of each other, then what's going to happen here? They cancel. ln of e make 1, so they cancel. So guess what my answer is? Done. Guess what this one is? Done. Well, now e raised to the power of ln, it has to be e raised to the power of ln, not e times ln, okay? E raised to the power, they cancel. Answer's 3x. And what's this one? So what would it be, though? X plus 1. Done.
They cancel out for both when they multiply and when they're to the power?
Well, they cancel out for both. What are you talking about? They're inverses of each other. So it's like doing like adding, subtracting. It's just they're going to cancel each other out. Now, why are we allowed to say it's just whatever the exponent is? Well, there is a property that allows that. And I think you may have forgotten, and I'm going to give you all the properties right now. Properties, there's only 3. Okay, so we did this last year, but we did it with logs. I actually made you a chart. I can tell you if you look in your notes, you will see it. But we did it with logs. I'm just going to do it with ln because, again, ln is logs. It's just they didn't write the word log. They just put ln of e, in which we know is a base e. So here are the 3 properties you need to know. See if you can remember. And then this one, this is the one that we can do what we just did above. I'll show you why. Okay, so ln of x times y. Do you know how to expand that log? Do you remember that? Go, Jack, go. When you multiply, what do you really do with exponents? You add. Because again, logs are just exponents, so we add. What would you do if you divide? Subtract. What would you do when there's a power? Well, do you remember this one? You bring it to the front. So it's n ln x. Okay, that's why we were able to do this rule up here. We could just bring that square root of 2 in front, and then ln e is 1. So it's just square root 2 times 1. That's where that happens. All right, so with this understanding of log property, by the way, listen to me. There is no, I should have written this down in the other class. There is no property that allows ln of x plus y equals ln x plus ln y. That's not gonna happen. You cannot separate if you're adding inside of a log. You can only separate when you're multiplying, dividing. That's it. Multiplying, dividing. That's it. Okay? So don't be like, oh, these are the same. No, they're not. This actually means multiply. It's not the same. Okay? You with me? Just want to make sure that I get that because I still have people do it. I'm like, what are you doing? All right, so we're going to rewrite expand, then we're going to rewrite condense, and we're going to solve, and we're done. We out. Okay? ln of 10/9. Rewrite that for me. ln of cube root x squared plus 1 third. ln of x squared y over 5, and we'll do one more. ln of x squared times x plus 1. That is a cube root, Jack. I'm sorry. All right, so what I want you to do, and again, homework tonight, will say expand them. So rewrite this for me. This would be ln what? 10 minus ln 9. Okay? And you could rewrite 9 as like 3 squared. You could put the 2 in front, ln 3. I don't need you to do all that craziness, but we'll leave it like that. Okay? This one, what would I do here if I'm taking a cube root of x squared plus 1? What is that?
1/3 ln.
Very good. 1/3 ln x squared plus 1. Can I break this down anymore? No. Can't break down addition inside of a log. You can break down if it was multiplication inside the log. Okay. How about this one? A little multiplication, a little power, and a little division. How could I write it? What would go first?
2 ln.
The 2 would come in front of the ln x. Then you would plus, because you're multiplying it with y. And then you're doing what? Subtracting ln 5. Okay, and you can put these in parentheses if you want to, just to know to do it first. All right, and then this last one, what would you do here? There's actually 2 ways of doing this. Just so
2 ln.
Yeah, this is multiplication, is it not? So you can actually separate these two. And again, why are we doing this? Because you are about to take derivatives of ln's. And it's actually easier to take a derivative of multiple ln's than it is of this. This is like crazy product chain rule. Are you with me on that one? Whereas this is, oh, I can take the derivative of that. That's 2 over x. That's 1 over y. And you see, 0. So it's easy. All right. So this would be ln x squared plus ln x plus 1. Then I just bring that 2 in front. 2 ln x plus ln x plus 1. And again, you cannot separate x plus 1. Okay? All right. Again, let's do one more thing. And again, almost. Oh, I'm sorry. Yes, I'm sorry. So sorry. That was pretty fast there. All right. So now we're going to rewrite condense and then solve. You got it?
Yeah, I got it.
I'm just going to do 2 of these because I think if you have these, you'd be fine. Solve. I'm just writing out the rest of our problems so that way I can. Take the time to do them. Here we go. All right. So let's do this first one. Let's rewrite this. Let's condense it, meaning I just want one ln. So what do you think that would be?
X over, is that 5?
That's a plus 1/5.
Plus 1/5.
Fifth root of y.
Yes, it's x times the 5th root of y. That's what that means. Or if you had written xy to the 1/5, I probably still would give you credit for it, but that's what that means, okay? How about this one? Here's the power. Here's the power. Always do your powers first. Then what would it be if you're minusing? Ln what? X plus 2 squared over x cubed. And you don't have to FOIL or anything. Leave it like that, okay? So condensing pretty easy. All right, last but not least, this solve section, okay? Need you to remember how to do these. Very important. Since e's and ln's are inverses of each other, that's how you solve these problems, okay? To undo an e, you take the ln. Write that up here. To undo the e, you take the ln of it on both sides. But to undo an ln, you take the e. These are the inverse operations that will help cancel the things out, okay? Or to solve for the exponents, really. So looking at this first one, I have an e. I want to then use ln. And the way that I use it is I say ln this side, ln this side. You have to do the same to both sides. The ln and e cancel to 1, the x moves in front, and your answer would be ln 5. Done. You don't narrate anything else. Don't tell me what the decimal is, just write ln 5. Unless the directions on homework tonight say it's decimal, whatever. All right, but what do you do on this one first? Don't do the ln yet. Yeah, subtract the 10. Okay, you want the e to be by itself. So you get, let me move it over here. E to the 0.1x equals 4. Now ln it. You get 0.1x equals ln 4. By the way, 0.1 is what fraction? Because let's be even. So this is 1/10 x equals ln 4. So how do you undo 1/10? You multiply by 10. So the final answer is actually x equals not ln 4 times 10, which is ln 40. No. Put the 10 in front. Remember us doing this? 10 ln 4. 10 ln 4 is the correct answer. It's beautiful.
Is that the same thing as ln 4 to the power of 10?
Yes, it's the same as ln 4 to the power of 10. Exactly.
Wait, that's not 10 times ln 4?
It is 10 times ln 4. But I'm saying don't write ln 40. Okay, now I've got ln. How do I undo ln? Listen to me. You don't put e on this side. Listen, it's e to the power of that, e to the power of that. It's not 5e or e times 5. It's e to the 5th. Are you with me? So this would cancel, and you'd be left with x equals e to the 5th power, not 5e. 5e is totally different than e to the 5th. Completely different. All right? So we do the same thing over here. 3 plus 2 ln x equals 7. Well, first of all, try to get your ln by itself. So what would I do first? Subtract the 3 and get 4. Then do what? Divide the 2. So I get ln x equals 2. Then, once the ln is by itself, e it. E to this power, e to this power. They cancel. X equals e squared. And that, my precious ones, is the end of today's lesson. You have homework, page 287, 2 through 12 even, 16, 20, 24, 28, 30 to 66, but every other even, and only do the A and B. It looks like a lot, but we counted it in the other class because they were all complaining. it's only 20 questions, and half of them are doing zoop, zoop, like that. So really, now they look pretty bad. They look menacing. Like this is, like I said, this is the first one, and it's like saying, write it in exponential form. Well, just put a little e here, and go like that. And so there's your answer. Here's first one done. Okay?
Yeah.
Can you flick on that light for me, honey? All right. All right, hold on a second. Let me just pause this so I don't